Hi, in this video we're going to look at what's the difference between constant and variable acceleration. And the reason we need to know about constant acceleration is that it's very important for the Suvat equations in mechanics. So here we've got two cars, we've got a green and a red car. They're going to race along the track here until for 8 seconds only. Okay. And what I'd like you to do is just a watch to see which one has the constant acceleration and which has the variable acceleration. And then after we've done that, we'd look at the graph, just try and explain why. Okay, so we're going to start the race here. So this app, before we start, is linked into the notes of the video, so you can look at it for yourself. So here we go. The start. So the green car starts off faster. It gets a bit faster. Okay. And we can see that the red car catches up. In fact, they both finish at the same time. We'll just reset that and have a look at it one more time. And you can look at this yourself using the GeoGebra app for yourself. So I think we can see there that the green car has the constant acceleration and the red car has some sort of variable acceleration. So let's just reset, and this time we'll do it drawing the velocity time graphs. So drawing the velocity time graphs, so we'll start again here. And what we can see is that the green graph, the graph of the green car, is a straight line, but the velocity time graph for the red car is actually a curve. So what happens in the case of the red car is that it starts off slowly and then it starts getting faster more quickly. So we've got some sort of slow acceleration here, and that towards the end it's sort of speeding up. However, for the green car, the acceleration is always the same amount each time. It's increasing by the same amount. And therefore, if we now do it as well with the acceleration time graphs, put in as well. So the dotted ones are the acceleration time graphs. You can see the acceleration of the green car is a constant. It's a constant at 8 meters per second. However, the red car, it is actually a curve. It's curving up at so it's a straight line. Beg your pardon, it's a straight line. But it's changing. The acceleration is not constant, it's changing each time. Okay, and we can also do this as well as looking at the displacement. By the end, they both should have gone, I think it's 256 meters, and that's the area underneath the velocity time graphs that gives us these. So here we've got all three things going up. We can see all three graphs happening at the same time. So the green area is the green car, displacement of the green car. The red one is of the red car. Okay, and we'll see at the end that they will both have an area of 256. Okay, so this GeoGebra applet is in the notes of the video for you to have a play with, to have a look at the idea of constant acceleration. So when we do an acceleration time graph, we get a straight horizontal straight line, as opposed to one which is going to change here, which is a line at an angle, i.e. the gradient has 3 here. Okay, and you can get the acceleration from the velocity graph by taking the gradient of the velocity graph, and here we can see that the acceleration here is changing. It's not always the same if you draw a tangent to this curve, and this is where we have the idea of differentiation, which we'll look at later. Okay, I hope you've understood. I hope this has helped you, and I thank you very much for watching.